Welcome back to Topic 45 for Algebra 2, Properties of Radicals and Solving Radical Equations. In Part 3, we're going to learn how to rationalize a binomial denominator and also how to solve radical equations, which may include extraneous solutions. First up, how to rationalize a binomial denominator, aka no rats in the basement. So remember how to rationalize the denominator. We do not want to have any radicals in the denominator. So what we can do is multiply the numerator and the denominator by root 2 over root 2 in this case, whatever is in my denominator. Now this is equivalent to 1 because root 2 divided by root 2 is 1. So we're not changing the overall value of the expression. Now we can just multiply across. Root 5 times root 2 gives us square root of 10. And square root of 2 times square root of 2 is the square root of 4. And now our denominator simplifies to 2. So we're left with square root of 10 divided by 2. Now we don't have any radicals in the denominator. So moving on to rationalize a denominator that has a binomial in the denominator, what we need to do is multiply by the conjugate of the denominator. Now we were introduced to conjugates dealing with complex numbers, so imaginary numbers. Let's try an example. How do we rewrite 1 divided by 2 plus root 5, which has a radical in its denominator, the root 5? What we first need to do is multiply the numerator and the denominator by the conjugate of the denominator. Here, the conjugate is written out for us. So we want to look at our denominator. Notice here how we have 2 plus root 5. Now similarly, with the example before, we had to multiply both the numerator and denominator because that means it would reduce to 1 and we wouldn't change the overall value of our expression. However, in order to rationalize the denominator, in this case, using the conjugate, instead of having 2 plus root 5, we need to have 2 minus root 5. So what we'll do now, after we identified what the conjugate was, is we're going to multiply the numerators and the denominators. In the numerator, we're just going to use the distributive property. So 1 times 2 minus square root of 5 is just 2 minus the square root of 5. In the denominator, however, we'll need to multiply. So we can FOIL, we can use the vertical method, horizontal method, however you like to multiply. I'm going to use the horizontal method, or how some people refer to it as FOILing. 2 times 2 gives us 4. 2 times negative root 5 is minus 2 square root of 5. Positive root 5 times 2 gives us positive 2 root 5. And positive root 5 times negative root 5 is minus root 5 times root 5 is square root of 25. Now, in the denominator, what we can do is we can subtract the terms. So here we have minus 2 square root of 5 plus 2 square root of 5. Those cancel, they add to 0. So all that we're left with is 2 minus square root of 5 divided by 4 minus, now the square root of 25 is 5. This simplifies to 2 minus square root of 5 over negative 1. Now because we're dividing by negative 1, 2 divided by negative 1 is negative 2. Negative square root of 5 divided by negative 1 is positive square root of 5. Or if we want to start with a positive number first, this is equivalent to square root of 5 minus 2. And that's how we simplified. Moving on to solving radical equations. What we first want to do when solving a radical equation is isolate the radical on one side of the equation, just like we would isolate a variable, except here we want to deal with the entire radical first. So I'm going to subtract 9 from both sides, and I will get square root of 6x plus 1 equals 16 minus 9 gives me 7. Now I'm going to raise both sides of the equation, specifically not just each term, but both sides, to the power that would undo the radical. So here we want to pay attention to the index. The index here, although it's not written, is 2. This is a square root. What would undo a square root would be squaring both sides. So I'm going to square both sides of my equation. Now, square root and squaring undo each other, so all I'm going to be left with is this radicand, the 6x plus 1. On the right-hand side, I have 7 squared, which is 49. Now what we need to do is solve the remaining equation. So this is just a linear equation. We can subtract 1 from both sides and get 6x equals 48, and divide by 6 on both sides and get x equals 8. Now what we want to do in the end is to check our solutions to make sure that they work and we don't have any extraneous solutions. So where we would get a negative under the radical, 0 in the denominator, things like that. So if I plug back in for a check, if we plug back in, we have 6 times 8 plus 1, square root of that, plus 9 should give us 16. 6 times 8 is 48. 48 plus 1 is 49. Square root of 49 is 7. 7 plus 9 equals 16. That is true. Let's dive into some examples now. In this first example here, we have square root of 2x plus 4 equals 8. So what I'm going to first do is I notice that my index is 2. So I'm going to raise both sides to the power of 2, square both sides. I'll be left with 2x plus 4, since taking the square of both sides is the inverse of taking the square root, and that's going to equal 8 squared, or 64. Subtract 4 on both sides. 2x equals 60. Divide both sides by 2. X equals 30. For a quick check, 2 times 30 plus 4, square root of that should give us 8. 2 times 30 is 60. 60 plus 4 is 64. Square root of 64 is 8. Correct. Let's move on to the next example. The square root of 2x divided by 3 plus 6 equals 8. So first I'm going to isolate my radical. Subtract 6 on both sides. So I get the square root of 2x divided by 3 equals 2. Now my index here is 2, so I'm going to square both sides to undo it. I'm left with 2x divided by 3 equals 2 squared, or 4. Now I can multiply both sides by the reciprocal of 1/3, which is 3. And I get 2x equals 4 times 3, or 12. Divide both sides by 2 to solve this one-step equation. and x should equal 6. Time for a quick check. 2 times 6 divided by 3, square root of that, plus 6 should give us 8. 2 times 6 gives us 12, divided by 3 is the square root of 4 plus 6 equals 8. So that's 2 plus 6 equals 8, which is true. Next example. 4 times the cube root of x minus 5 minus 13 equals 3. Just like we would have a two-step equation if this entire quantity was just a variable, like what we want to isolate, we're going to first add 13 to both sides. So 4 times the cube root of x minus 5 equals 16. Divide both sides by 4. And the cube root of x minus 5 equals 16 divided by 4, which is 4. Now here, the index is 3, so we're going to cube both sides. This will just leave me with the radicand, x minus 5, and 4 cubed is 4 times 4 times 4, or 64. Add 5 to both sides. X should give me 69. Now we can do a quick check. So 4 times the cube root of 69 minus 5 minus 13 should give us 3. 69 minus 5 gives me 64. The cube root of 64 is 8. Not 8, it's 4. 4 times 4, goodness, minus 13 should give us 3. 4 times 4 is 16. 16 minus 13 equals 3. Perfect. 2 more. Okay, next example, we have the square root of 3x minus 2 equals x minus 4. Now here the radical is already isolated. So my index here is 2, and I'm going to square both sides in order to eliminate that radical. So I'm going to be left with 3x minus 2 equals x minus 4 squared. Now if I multiply that, I'll get x squared minus 8x plus 16. Now I want to solve for x. So I'm going to add 2 to both sides and also subtract 3x to get 0 on one side. I'll be left with x squared minus 11x plus 18. Now in order to solve, I can factor. So 0 equals 2 factors. These 2 factors need to multiply together to get positive 18, but add together to get negative 11. So I will have x minus 9 and x minus 2. Using the zero product property, x could either be positive 9 or positive 2. So now I'm going to check. If I plug 9 in, I'll get the square root of 3 times 9 minus 2 should give me 9 minus 4. 3 times 9 is 27. 27 minus 2 is going to be the square root of 25, and 9 minus 4 is 5. The square root of 25 is 5. Let's check the other value. The square root of 3 times 2 minus 2 should equal 2 minus 4. 3 times 2 is 6. Subtract 2 is 4. So we have the square root of 4 equals 2 minus 4 is negative 2. Now here is where we have an error. Because this 4 is a principal root, For this even root, the answer has to be positive. It cannot be negative. So in general, when we want to take the square root of a number, that should equal a positive number. However, it might be a little bit confusing because if we think that x squared gives us 4, well, the two possible values for x are positive 2 and negative 2. So it's in that case where we have our two solutions for x. However, if we're just simplifying the square root of 4, because we're dealing with the principal root, this answer has to be positive. So, this answer of 2 here is extraneous. So our only answer is x equals 9. Moving on to the final example, the square root of x plus 9 minus the square root of 2x equals 3. Now we want to isolate the radical. So in this case, what we're going to do, because we eventually will want to square both sides, is we're going to add square root of 2x to both sides. We'll be left with the square root of x plus 9 equals the square root of 2x plus 3. Notice this 3 should be on the outside of the radical. It should not be included with the radicand. Now what we can do, because the index is 2 here, now we can square both sides. On the left-hand side, the square root and squaring will just leave us with x plus 9. They undo each other. And on the right-hand side, we'll have this binomial times a binomial. Square root of 2x plus 3 times the square root of 2x plus 3. Now we can FOIL or multiply to get x plus 9 equals square root of 2x times square root of 2x. Since we have the square root, and this is really the square root of 2x squared, they will undo each other, and we'll just be left with, again, the radicand, or 2x. Square root of 2x plus times positive 3 gives us 3 times square root of 2x. 3 times square root of 2x gives us 3 square root of 2x. And 3 times 3 gives us 9. So we're left with x plus 9 equals 2x plus 6 times the square root of 2x plus 9. Now ideally, I want to solve this radical equation, so I want to solve for x. I can subtract 9 from both sides, and that will cancel. So I'll be left with x equals 2x plus 6 times the square root of 2x. Now what I can do is I can subtract 2x from both sides in order to solve just for x. Now in this case, I'm left with negative x, because x minus 2x is negative x. So that will equal 6 times square root of 2x. Now in order to eliminate my radical, I'm going to square both sides because the index here is 2. If I have negative x times negative x, a negative times a negative is positive, so this will leave me with just x squared equals, now 6 squared times square root of 2x squared. This will leave me with x squared equals 6 squared is 36 times 2x. So x squared is going to leave me with 72x. Now what I can do, in order to solve for x, I can subtract 72x from both sides and get x squared minus 72x equals 0. In order to solve for x, I can factor out an x, get x times x minus 72 equals 0. So now I have two possible values for x. X could equal 0, or x could equal positive 72. But I need to check them to make sure that neither of these answers are extraneous. If I plug into the original equation, let's plug in 0 first. So I have the square root of 0 plus 9 minus the square root of 2 times 0 should give me 3. Now the square root of 0 plus 9 is just the square root of 9, which simplifies to 3. The square root of 2 times 0 is the square root of 0, which is 0. 3 minus 0 is 3. Let's try the other value. If we plug in 72, we have the square root of 72 plus 9 minus the square root of 2 times 72 should equal 3. Now 72 plus 9 gives me the square root of 81 minus 2 times 72 gives me 144. When I simplify those radicals, I get 9 minus 12 equals 3, which is incorrect. It equals negative 3. So 72 is not an answer, it is extraneous. That is part 3 of topic 45, properties of radicals and solving radical equations. Thank you for watching.